Alright, section 6.2 deals with, again, polynomials is what we're focused on, and what we're going to be looking at is linear factors of it. So we're going to be taking polynomials and we're going to be breaking them down into x minus a number, x plus a number, 3x minus a number, and so on and so forth. We've done some of this already with quadratics, using the quadratic formula, but now we're going to be expanding it to using cubics, quartics, etc., etc. So the first thing you want to do is, if you're given your linear factors, which are these right here, x plus 5, x minus 4, x plus 1, if you're given those and you're asked to put it into standard form, how would you do that? And essentially what you're doing is you're going to be factoring, or you're going to be foiling first, outer, inner, last, first, outer, inner, last. You're going to be foiling each of these. So like you see here, I've got the first two in red, and then I've got the second one in green. So what you'll do is that you'll foil these first two. So the first x times x times -4, 5 times x, 5 times -4. And you would multiply those out and you get that blue function right there. And then you would simplify it down. Okay. Now whatever that new one is, that new blue function, now you're going to multiply it by the third one, x plus 1. And when we multiply it, we would take this x and multiply it to every single part, and this 1 would be multiplied to every single part. So we'll end up with 6 terms in which we're going to have to simplify after that. Okay, this is a lot of multiplying and getting everything together. So this is what it kind of looks like when I've got it all set up. So then you would multiply, so the first one would be an x cubed plus x squared plus x squared plus x minus 20x minus 20. And then from there you would simplify. So you would combine like terms and get it down. And that is your answer. Okay, that is the standard form using those linear functions. Linear functions or linear factors. Okay, so when you have these, you're just going to FOIL it all the way through. So it takes some time. You've got to make sure you keep everything in order. Now factoring. Now factoring is a little bit, it's kind of an extra step than what we've done with the quadratics. And so what we'll do here is that we want to see, is there anything we can take out of every single one of these? And by looking at it, we can take an x out. Okay, and then we can also take out a 3. Okay, now when we take that out, we're left with 2x squared minus 5x minus 12. Okay, and now when we have these right here, we would use our normal quadratic. We'd multiply 12 times negative 12 times 2, which is 24. Factors of 24, that gets you 8 when you add them together, or negative 24. Added together gets you negative 5. So you've got 6 and 4, you've got 12 and 2, you've got 8 and 3, which is going to be 8 and 3 would be your answer. And so then you would factor it all the way down. So the factors, I'm factoring just this part right here is factored there. Combine, combine, and as you see, factoring out. You could also use your quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. That would also work. Okay. Again, we're factoring. So it's kind of like what we've done previously, but we're taking the extra step. Okay, the factor theorem. The factor theorem, the expression x minus a is a linear factor of the polynomial if and only if the value a is a 0 of the related function. So if you have a factor that comes out as x minus a, okay, so like what we had previously here, this right here, x minus 4, that is a factor. The only way that is a factor based on this statement is that if you plug a 4 in, you get a 0 in the function. So if we look back here, if we were to plug a 4 into all the x's, we would find out that it actually does come up as 0. We zero out the function. And that's what we're going to be looking at in this chapter, and we're going to be looking more in depth about. So now the next one, write the polynomial with the zeros of 3, -5, and 9. So what you'll do is that you'll write these out. It's going to be x, then you change the sign. So it'd be x minus 3. It'd be x plus 5. And then x minus 9. And now all you have to do from here is what we did previously, one of the first things we did, which is factor this out. So we would multiply, or we'd multiply it through. So x times x, x squared, x times 5, 5x, -3 times x, -3x, -3 times -5, 15, combine like terms, and everything. So as you see, we combine, we get this, and then we multiply x minus 9 into each part. And then you simplify it down. And this right here has the zeros of 3, -5, and 9. So if we were to plug a 3, a -5, or a 9 into this function, it would come up as 0. Okay, and you can go and you can check that on your own. Multiplicity. Now if you have a factor that is the same, so in this case -3 is the same. We've got it in two parts, so we've squared it. You would say that the multiplicity of it would be 2. So -3's multiplicity is 2. If you repeat any number as a 0 in your answer, then you would say that it has a multiplicity of that number. Okay, it's just kind of a math term that you'll see here and there, and it's just good to know when you see it. So it just means that that number's been repeated. Okay, so your IRAT here, what you're going to do is you're going to write the first one in standard form, so distribute it all through, FOIL it through. Okay. The next one I want you to factor, so see if you can remove anything, factor out anything, and then break it down using either quadratic formula or multiplying the first by the last and then seeing what the two numbers. It should come up as nice round numbers. And then the last one, I want you to write the polynomial that has the zeros when x is 5, 6, and 7. Okay. So again, write out those into this form and then multiply it through. Okay, and that's your IRAT for this section.